Yeah, so this question is to implement a stack that also has a method where you can return the minimum element in that stack. Have you heard this question before?
Yeah, I've definitely done this one before, and just I guess outline the approach. So you have two different options. One is to create a separate stack, one that just keeps track of the normal data, and a separate one that keeps track of the min values. And you would, just get the min value in constant time from the second stack, right? Alternatively, you can just make it that you keep track of 2 points of data in a single stack. One being the actual data, the separate one being the min. And you'd pop data on and off accordingly, right, based on min values that you find.
Okay, so yeah, let's do a different one. Okay, here's another question. This one's also pretty common, so tell me if you heard this one. So this one is about sort of a linting question. So given a string that contains, different types of parentheses, you're trying to lint that string effectively and determine whether the parentheses properly close themselves. Have you done?
Right. So I'm guessing this is either with just parentheses or even with other data in the middle, right?
Yeah, I mean, I guess it's a pretty similar question, but I mean, if you haven't heard this question before, then we can go ahead and do it.
Yeah, I want to say that this one also sounds pretty familiar in the sense that I should be able to pop on, the open paren types, depending on what type they are. If they're any of, the square or regular or the squiggly ones, then you would just pop those onto the stack. Whenever you see the closed versions, you would just kind of pop off the stack, check if there's a match. If there isn't, then you know that it's not properly closed. And at the end, your stack should be empty.
Yeah, okay. Yeah, so I see I prepared not very well for this. Okay, so let's go on to another one, and this one is not as common and is a little more difficult. So, okay, this one, and again, tell me if you've seen it before. This one is called daily temperatures. And again, I'm just gonna copy and paste this off of LeetCode right now. So let's see. So yeah, I'll just give you a second to read it. I think that's better than me reading it to you.
So at first glance, I don't think I've done this problem, but I'll just read over it.
Okay, cool.
Okay, so I guess just from my understanding of the problem, I'm given an n-length array of temperatures, and I want to return an n-length array as the output that just tells me how many days from that point I would have to wait until a warmer temperature, right? So in the case of the 0th index in the example, because 74 is warmer, I put 1. Similarly for when I have 74, 75 is next, so it's 1. But for 75, nothing is higher until 76. So one thing is, just to make sure that I understand the output correctly, I guess it's 0 if you end up never getting, warmer temperature, right, after that point.
That's correct, yes.
Okay, sure. So thinking this through as a naive approach, what I could do as, say, an n-squared approach is to, for each index, look at its value and then keep iterating forward until you find a temperature that's higher. And you would repeat that for every index in order to get your result array. But that is, big O n-squared runtime complexity solution, right? It takes constant space to do that. Because all you're doing is keeping track of, 2 pointers in a sense, right? So does it help to kind of reverse this? Say start from the end pointer or the end index and then go to the front. I want to say not really, because it's really just the exact same operation, right? So the biggest improvement we could get for runtime complexity is to probably use some additional space. Just because if we were to use two pointers and sort of vary the length, there's nothing that really tells us how, say, those 2 pointers should advance, right? If you have a forward pointer and a back pointer. Yeah.
Yeah,
So if we
yeah.
were to instead use an n-length array to store intermediate data, what would you really want to store? Let's just see from the very first example. So I know that the max to this point is 0, right? Or negative infinity, because there's...
Sure.
Okay, maybe it's more useful going from the right side. The max at the point of looking at the last index is going to be 73. And because it's the last index, I already know that the days until a larger temperature is going to be 0, right? When I look at the second last index, if I look at the max temperature that I get going to the right, I should be able to know that that is 73, so I should similarly have 0. But there's no spacing information that I'm giving, in the sense that when I look at one value to the right for the highest temperature to that point, even if it was a higher value, say it was a 78, that doesn't really tell me anything, right?
You mean you're just storing the value of the higher temperature? You're not storing the index of the higher temperature?
Yeah, and even if I were even if I were to store the index of the highest temperature, that's not good enough, right? Because let's say I get something like a 70, let's say 78, 79. The temperature that I have that's higher, that's highest is going to be 79, right? But the first larger temperature is actually the 78.
Yeah, so you mean 76 would incorrectly return 2 instead of
instead of 1, the way it's supposed to.
Right.
So let's think about, I'm confident I would need an array as the intermediate data, just because the other structures that I can think of don't really have any property that helps out, right? Like if I were to use a stack, is that useful? Let's see, going from the front or the back, if I were to use a stack of highest temperatures, no, if I add higher temperatures as I go along, or I guess a heap has some information, right? That's the only structure I can think of that maintains some kind of max, but yeah. So a heap seems useful to some extent, because instead of doing an n squared solution, I know that I should be able to get an n log n solution somewhere here, right? Because what I should be able to do is, as I'm going through from the right side, I should be able to put my items onto a heap, a max heap, as I'm iterating through, which keeps track of the temperature as well as the index. And when I get to the point, when I get to the left pointer, or the left index of that point, I can look at the top of the max heap. I don't see a way that I can avoid going through all of the items in the heap, because I would definitely want to find the the value that is higher, but at the same time it's going to be the lowest index, right? So if I were to go through all of the items, that's still kind of an n time operation. So this is actually no different from the n squared that I mentioned earlier.
Yeah. I see your point, yes.
If I were to change the structure of the heap somehow, though, does that really make a difference? No, because the other thing I could order on is just the index itself, right? In which case the heap is pretty much useless.
Right. Can I offer a hint at any time?
Sure.
Well, I'll just say that if you notice a pattern in the first 2 questions, I guess that pattern extends to this question as well.
So you're saying a stack would probably be useful for this as well?
Yeah, and the only reason I say that is I guess it's not really a good question without knowing that, because it's kind of a gotcha question. You know, it doesn't have a really good iteration built into it.
Okay, I guess earlier I mentioned the stack, but I dismissed it outright, but I didn't really explore it. So let's see what happens if we use a stack. I'm thinking that I'd want to go through from normally for a lot of these problems, you'd want to iterate from the left side, but for this one, it seems like you'd always want to iterate from the right, right? Is that true, though? Because I think last time I said from the right, it's not really useful. But if we were to go from the left, let's say I put 73 onto a stack. What does that really help with? Again, seems like little, because in order to find the first value that's greater, I'd actually need to iterate through the entire array, right? So if I were to iterate from the right side, I'd put the rightmost 73 onto the stack. The next time through, when I see the 76, I imagine I would want to put the item onto the stack because it's larger, but how does that help future operations? Aside from me just going through the entire stack. So maybe instead of having just the normal stack I had, if it was a modified stack, right? If I were to have a min operation on the stack and a max operation on the stack, that kind of gets me the bounds of what values I could find, right?
Right. I think that's getting back to maybe the original problem, where you don't just need the min of what's behind you or in front of you. You sort of need
the max as
right.
well.
Well, not just the min and the max, but you just need to know the next one that's larger, not necessarily the min or the max, right?
Right. But it seems like there's no way for me to get in constant time the next one that's larger, just from using a stack, even if it has the min and the max. Because let's say I'm at the value of 75, and I know that all of the values that say were, I think at some point I would store 72, at some point I'd store the 73, and at some point I'd store the 76, right? Is that going to be
okay? I see where you are. Yeah.
Is that necessarily going to be in order? Because if it was just the stack that was appending at every single step, that's the same as just using an array, right? But if I were to avoid appending to the stack any of the steps, then I would lose out on information. Like, let's say I had the 69, which is lower than every other number on the stack, and I chose not to add it. If I had a 68 at the front, I guess it doesn't matter, because I do still have the 73 that's the first number larger, right? So even if I don't add that 69 onto the stack, in this case it doesn't really matter. What if all the items that come after the 69 are much smaller? So let's say I just had the 68 here and then 69. In that case, that 69 is relevant. So for the most part, it doesn't seem like there's any distinguishing. There's never a point where you don't add an item to the stack. So the only other option really is to reorder items in the stack.
Maybe it would help to sort of consider a couple extreme cases, like what if the array was ever increasing, or what if the array was, ever decreasing?
Sure.
Like how would the algorithm look?
5. So if it was always increasing, then I know that the result is always going to be just 1, right, at every step, except the last one. If that's the case, still the first time when I have that 5, I'd want to put it onto the stack. When I get to the 4, I know that the 5 is the first value greater. So I guess one thing I didn't consider is maybe pre-processing the entire array and then going through it a second time. Because I think I've just been thinking about going through it, one at a time, right? It seems like there's no way I can predict what the next number is going to be, right? So after I've used the 4, there's no way that I know whether the value to the left is going to be less or greater than. So if I were to, instead of just iterating through once, what if I were to, for each number, try and flag whether there is a number that is greater at all, right? Just like a Boolean, let's say.
Okay.
This doesn't seem to really use a stack much, but if I were to store, true at all of the steps, then
So sort of walk me through it, I guess. So we're iterating from in reverse order, right?
Yeah.
And so we look at 5 and.
Right, so I haven't really come up with an algorithm for how to do it, right? So there's, for what I was suggesting, it was that I could have a Boolean, but looking at this again, that's still useless, because even in a first iterated step, I could just, keep the max that I found going through the array, right? So this is not adding any information. Okay, let's try and I guess just go through this example. So what I was thinking before is I would add 5 to a stack, and I know that the min is equal to 5, max is equal to 5, but I'd also want to store its position, right? Second time through, I should have 5 at position 4 and 4 at position 3, and now the min is equal to 4, the max is equal to 5. Same thing. It seems like it'll just repeat, right?
Right. Yeah. So in this, are you thinking of doing? Is this one pass to sort of gather information, and you're thinking you're going to come back in a second pass and use that information,
or? I was thinking of this as just being the first pass. But if I were to go through this entire thing, with multiple passes, then so the part that I'm not really seeing any point of is that the stack doesn't really seem to bring any, because I'm adding things to the stack every time, no matter what, the stack isn't really bringing any value that the regular array doesn't, right? Because the array is already set up as a stack if everything's always being added.
Yeah, sure. I'm not, just because I'm not that experienced at iterating people, I'm not sure if I'm giving enough feedback, but I'm ready to give a hint, more hints at any time.
For how sure.
Okay. So what if we use the stack to keep track of things that have not found the next largest temperature?
So using a stack to keep track of things that did, items that did not have a larger item. So in this case, sorry, go ahead.
Oh, go ahead.
I was going to say, so you're meaning keeping track of the 76 and the 73 because there's nothing larger?
If we were to, well, I guess the other hint is that at least in, I guess, the solution we're going towards would be to think about iterating front to back instead of back to front.
I see.
And then the hint I was giving before was that, maybe we could keep track of things that we've seen where we haven't seen something larger as of yet, as of wherever we are currently in the array. Does that make sense?
Okay, yeah. Yeah, so if we were to go through from left to right, that means that the very first time we would store the 73, and then we would want to keep on adding. Okay, yeah, this is definitely a super useful hint, and especially points out the mistake with going right to left. Because if you were to use a stack and go from left to right now, and just kept track of things that you don't have solutions, in that case, what you should be able to do is keep on adding to the stack while the items are smaller. But as soon as you have a larger item, what you should be able to do is fill in that smaller item's distance with the larger item. Meaning, I guess to make it more concrete, say you start off with 73 the first time, you would store 73 in index 0, right, to indicate where that 73 is from. And then when you see the 74, you see, oh, this value is greater than the top. So while the value is greater than the top, you would fill in the index that you found with the distance to the current index that we have. So when we compare the 74 and 1, we would say that distance of 0 is equal to 1 minus 0, which is equal to 1, right? And we should be able to repeat this logic for all the indices. And this way you do end up making a linear time solution for this, but also linear space. Because you only have to visit each index once.
Yeah. So what would happen, I maybe walk through when we go through, we hit 75, 71, 69, 72, just looking at the example.
Yeah, so when you get to 74 doesn't have a solution, but 73 was just found. So then you'll add 74 to the stack, as well as index. And this kind of repeats the same logic as what happened with 73 repeats when you hit 75. And then 75 gets put onto the stack with 74 put as 1. The next time through, 71 is not lowered. So your stack is going to be updated to 75, 71. 69 isn't lower. Then now you have 69. 72 is lower than, or higher than 69. 69 gets popped off of the stack, but the 72 gets added. So now you have 75, 71, 72, as well as, their indices. And now you hit 76. Oh, this is larger than 72, so you pop. It's larger than 71, so you pop. It's larger than 75, so you pop. And then finally you have 76 on the stack. And when you go through and end up visiting all of the indices, and you still have items left over on the stack, you just set all of those indices to 0 for the items that are in the stack.
Yeah, that sounds really good. And we've talked about the complexity. Yeah, so if you want to start writing at any time, that sounds good to me.
Sure. So I'll just, I'll be coding this in Python, and I guess I'll call this, what is it, dist days, I guess, on temps. Sure. So let's say that our result is going to start off as 0 times n. Result. In the middle, all we have to do is iterate through each of the indices. Right, so what I ended up saying, just to make sure that I handled these edge cases correctly, the very first time, I don't really have anything on the stack, right? So if the stack is 0 or empty, then in that case, no matter what, I would just append the item. To make this simpler, I can use in value and enumerate on temps, and then say if stack lineup stack equals 0. In that case, I would just append to the stack without any comparisons. Otherwise, I would want to do the other logic that I talked about, which is that if the current value that we're looking at is greater than the top of the stack, in that case, we would want to, pop off. So do a continue here, and then not use them. if temp is greater than stack of -1, this should be a while. We're going to say that the temp prev_ind equal to stack.pop, and we're going to set the result of prev_ind is equal to the current int minus prev_ind. And when we finish all of this, we should just have to stack.append temp in. So just, I guess, going over what we ended up doing to make sure this was the correct translation of what we talked about in the code. The if case is simple in that all we're doing is just, appending to the stack if there's nothing there. Otherwise, while our current temperature, there's a bug here. It's supposed to be while the temp is greater than the temperature at the last element. So I need to do the last element at index, the first value. I'm going to just pop off the stack by getting the previous ind. And I'm going to say that the previous ind is the difference between current ind and that previous ind, which if we do the 1 minus 0 calculation, I think it works out. And that should keep repeating while there's still items you can pop, but there's still a bug here in the sense that I actually need to do while len of stack not equal 0 and that the temperature is greater. Otherwise, I'm going to do, I'm going to end up trying to get the last element on an empty stack, right? Which is a case that we can hit. And finally, when I've gone through all the elements, the only thing I'd want to make sure I do is to iterate through the stack and make sure that all of those values are set to 0. But if I think about it, for how the code is set up, that shouldn't really be necessary, just because I set the initial values to 0. So I think this ends up being the translation I'd want. Is it okay if I run through some test cases on this?
Yeah, let's do that.
Cool. So is it okay if I actually do the print, or would you prefer like the line by line?
Oh, just print,
like manual trace. Okay. So let's just do the example given to start.
So I think you're in Python 2, by the way.
Yeah.
So the print is...
Oh, it doesn't require that. I guess it still works out. Yeah, I think it's only if you have it the other way around and you're doing Python 3. In that case, without the braces, it doesn't work. Yeah, so looking at this example, it seems to work out. Everything matches with their output. Let's go ahead and add some more test cases. So the edge cases that we care about really are that if it's always increasing, that's 1. If it's always decreasing, that's a special case, 5, 4, 3, 2, 1. We'd want to check the empty array to make sure that that doesn't bug out. Do we have to care about negative values? No, that's the same because, positive and negative are the same on this. It's just numbers on a number line. I want to say that should be major test cases. The regular test case handles a lot of the other edge cases we might want, in which that there's a, an up and down. It's running this, cool. The all increasing one seems to work out. The all decreasing one seems to work out. Same with the empty array. So given that, I think that'll be my solution.
Yeah, it looks great. So let's see. I guess we can go into a more informal section. Let's see. I'm just looking at the code, and I'm thinking. I believe that we could maybe cut the amount of space we store in the stack in half.
Okay.
Does that make sense to you? I mean, we could store half the amount of things that we store on the stack.
Yeah, you're right, in the sense that the temperatures, we don't really care about that, right? So if I were to actually remove the temp value, oh, sorry, that doesn't work out. because I do still need the temp comparison, right?
Right.
Yeah. Well, not entirely true. I don't need the temp comparison. I can just remove the value there, and all I should have to do is say if the temperature I'm looking at is greater than temps of stack -1. In that case, I should just be able to do this and look at just the indices.
Yeah. Do you want to run that again?
Yeah, it seems to work out fine.
Okay, cool. Yeah, I think that's as best as we can possibly do.